Hi, and welcome back to Haskell for Dilettantes. The channel is Tea Leaves Programming, and today we're programming like it's 1979. Yes, I know Haskell didn't exist in 1979. Shh, don't tell anyone. We are working on Homework 2 of CIS 194 by Jochen Breitner, and we just did Exercise 1 in the previous video. You should go watch that first if you haven't yet. And now we're going to work on Exercise 2. Before we do that, well, let's look at Exercise 2. Look the right way. This is an extension of Exercise 1. We want the figure to look the way it is going. So write a function player2 from direction to picture that draws the figure in 4 variants. Then extend the code. So after the player has tried to move in some direction, it looks that way. If you can reuse functions and types, do so, but if you have to change them, rename them by appending a 2 to the name. The resulting program should be called Exercise 2. So when I first did this, I believe I just kept mutating things in my program. I mean, in the text of my program. But I'm going to try and keep it the hot side hot and the cool side cool, reference for old people there. And we're going to keep our existing Exercise 1 code frozen in amber. However, before I do that, I'm feeling that this file is getting a little disorganized. So I'm going to reorganize it so that everything common is up top and that our exercise specific activities come later. All right, that is nice and neat now. So we can start thinking about Exercise 2. So I think the key word in the description of this homework is that. It's the word after. The word after means we're introducing more knowledge of the state of the world. So after the player has tried to move in some direction, it looks that way. So you're not just needing to look in some direction while you're moving it. You need to look in some direction and then keep looking that way, which means we need to remember the last direction we moved in. And if you think about, right, we have this type coord in Exercise 1. Right? The event handler goes from the state of the world to the state of the world. So the event handler takes the event, it takes coord as the state of the world for this polymorphic type in activity of. So our world state for Exercise 1, the only thing we know is what's this coordinate value. But now for Exercise 2, we want to know not just what coordinate is the player at, but what coordinate is the player at and where are they facing? Essentially, what was the last move is one way to think of it, although it's not strictly true. So that implies that at a bare minimum, we're going to have to rewrite every function from Exercise 1 that takes a coordinate. It's now going to take, instead of taking a coordinate, it's going to need some more involved structure that represents the state of the world. So what is this structure called? I'm just going to call it state. I think I can call it that. I don't think that's a keyword. And what does that state have? Well, we know it has the coordinate, right? Well, let's give it a constructor. We'll give it a constructor S. Why not? And it takes a coordinate and it takes a direction, where coordinate is the square that the player is currently in and direction is the facing, essentially. I think that's all we need for right now. We may need to add more things. Certainly, once we start moving around these boulders, I know they don't look like boulders, these blue squares, once our game needs to keep track of where those are going, we can be certain that this state is going to expand yet again. But We're not being tasked with that yet. So let's just do this coordinate direction state. All right. What all do we need? Well, let's start out. This is going to look very similar, right? It's going to be exercise 2. Okay. And instead of initial chord, we're going to have an initial state. Oh, I can't do that, can I? Call that undefined. Let's do these things one at a time. Instead of initial chord, we're going to have an initial state. Initial state is just a state. I keep hitting this bug where the space doesn't work after typing certain symbols. So our initial state is going to be, what did we say for initial chord? We said that. It's going to be S, and then that coordinate. And let's have it face right. Just so that we can see something different. Right now it's facing up by default. Do I need these parentheses? I think I do. Let's take a look. Yeah, we need the parentheses. Okay, we called this event handler. Let's call it, we'll call it handler. Handler 2. I'm going to put 2 on everything here because otherwise it's going to be nuts to try to keep track of it. Once again, I'm just going to copy our initial code since this is a fairly small change. Right? And instead of going from chord to chord, it's going to go from state to state. This part is correct. This part is not. And try move is clearly, well, is try move going to need to change? Yes, because try move because the try move, let's look at it. Try move takes a coordinate and a direction and returns a coordinate. But we don't need this to know anything about our state because we have the direction up here, I think. All right, well, let's try deconstructing one of these things in our pattern. Okay, so we've got a state. And that state has some coordinate, like so. And it has some direction, like so. I think this is actually correct. But instead of returning a coordinate, so let's just focus on this, okay? We're taking the event and we're decomposing the event. That's correct. We're taking a state and we're decomposing the state. That's correct. We need to return a state. This returns a chord. So one thing we could do is make this return a state, but I like reusing code when I can. Maybe I'll regret this. So instead, let's keep that coordinate and return a new state, like so. So we're basically constructing a new state using the existing try move function to do so. This is wrong, however, because this, as we established, is the last direction, right? That's the previous direction. So in fact, we don't even need it. All we need to know is our new direction that we're going to be facing. That's what we're trying to remember. And so that's going to look like this. And I think if we do this for each of these 4 cases, changing the direction appropriately for them, that's what it looks like. Oh, and I have to do that as well, right? You know I'm going to spend some time adjusting the indentation. I apologize. Okay. Yes. Yes. Right. Okay, and then for everything else, we just want to return the state. So if I'm right, that is our modified exercise 2 event handler. I think that's correct. I guess the reason to modify try move and update that to take a state and return a state, you know, maybe you could not have this repeated constructor here, but I kind of like this better. So I'm going to go with this. All right, now that we've got our handler, we want to draw our state. So I'm just going to call this draw2. Our drawing function, if I recall correctly, which I don't recall at all, goes from coord to picture. Let's go ahead and copy this down here just so we can see what it looks like. So instead of going from a coordinate to a picture, we're going from a state to a picture. If you're confused about how I can just change coordinate to state, I'm going to reiterate this. If we look at our entry points, note how this type, this world type in activity of, has a lowercase. That means that it's not a type. It's a polymorphic type, essentially. And it can be anything at all. And we're going to treat that as the state for this function. So that's how we're able to do it. All right, so what do we need to be able to draw? Well, we know we're getting a state. And we know that state has a coordinate. We know that state has a direction. Right? Oh, and I'm calling it draw world instead of draw 2. There we go. And I need parentheses here in order to decompose in the pattern matching. Okay, so as of right now, we're not doing anything with our state of what direction the dude is moved. So we're not actually changing the drawing, but everything else should work correctly. The moving around should work correctly. So let's try that. Let's go up to main, change exercise 1 to exercise 2. And if I've done everything right, then we should be back where we started at the end of exercise 1. It looks like we are. We can correctly, collisions being handled correctly. All right, so now we have to actually use this state. You might notice that we're not using this direction whatsoever. So, what could we do? Well, the kind of obvious thing that I'm thinking is we could pass down this direction to some, into this player function, but then we're going back and we're changing common code. I'm wondering if Code World has a way to rotate shapes, because if it does, rotate pictures, excuse me. Because if it does, then maybe the simplest thing to do is just rotate by however many degrees. Translated, scaled, rotated. Rotated double from picture to picture, a picture rotated by this angle about the origin. Angles are in radians. Okay. Let's go ahead and copy that and just drop it here. All right. So we know And this is actually using some external state that lives in our brain here. The morally pure thing to do would be to have our drawing function know what direction it's facing and draw accordingly. And the reason that's morally pure is it relies on no kind of external knowledge. But I'm lazy, and I know for a fact that I drew a triangle, and I drew it in such a way that it was pointing up. So I am going to pretend that I know that and that that's encoded in here. And so we're just going to rotate based on the number of the last direction moved. So probably the easiest one to do would be down. Let's make a new function called rotated player that takes a direction and a picture and returns a picture. Right? I think that's correct. And like so. Right, up, down, left, right. And using my external knowledge, I know that the up version is just the picture of the player. Actually, we don't even need to do that. We don't need an in picture here because we're not rotating arbitrary pictures. We're rotating one picture, which is just that, right? Down should be rotated. Angles are in radians, so does that mean I want to rotate it 180 degrees? Does that mean pi divided by just pi radians? I think so. And then left should be rotated pi divided by 4 player. This is going to end up being like wrong, and I'm going to have embarrassed myself on high school level mathematics. All right, so now I think we just want to do this. Rotated player direction. In fact, I'm going to use my dollar signs here. Right? Just to avoid too many parentheses. Let's see if that worked. I'm so nervous. Okay, well, good news, something happens. Bad news, what I expected to happen is not happening. That's awesome. I must have screwed up my high school geometry as promised. Really, my goal here is to make you feel better about yourself because, boy, I make a lot of mistakes. Yes, if 180 degrees is pi, then by definition, 90 degrees is pi over 2, not pi over 4. Let's see if this works. Look at that. And you'll notice, let me stop and run that again for you. You'll notice we said that our initial state was pointing right, and there it is. It's pointing to the right. So that is exercise 2 of homework 2. Let's go on and see what exercise 3 is. I'll see you on the other side.